Hi class, it's me, Mr. Morris, and we are talking today about forms of energy. We're introducing a new unit. So we've been talking a lot this year about matter, about different chemicals and things like that. But now we want to talk about something that is not matter, okay? And that is energy. Now we've got different forms of energy, and you've probably heard of the general forms before in a previous class. You've got potential energy and kinetic energy. You may have also heard about some of these other forms of energy, but we want to break it down in those two forms really quickly. Potential energy is stored energy. The really common one you've heard of before is the energy of position, which is gravitational energy. So if I have something that's at the top of a hill, it's got a higher potential energy than something at the bottom of the hill because it has that position where it could start making a lot of kinetic energy. Kinetic energy is the energy of motion, like waves, electrons, atoms, molecules, and substances. They all can have kinetic energy. It's the energy of motion. We tend to think of both of these in a macroscopic view and things that we can actually see, but they also occur on the microscopic level and submicroscopic when we're talking about atoms and molecules. Chemical energy is the main form of potential energy we're going to talk about. You've also got nuclear energy, stored mechanical energy, gravitational energy, and so on. Once again, the main form of energy we're going to be talking about here, the main form of potential energy we talk about is chemical energy. That's the energy that's stored in the bonds of atoms and molecules. Biomass, petroleum, natural gas, propane, those are all different types of chemical energy. We could also talk about nuclear energy. That's the energy that's stored in atoms. So when a fission or fusion reaction occurs and we actually get a different element out, that is a nuclear reaction, and nuclear energy is involved. We talked about that when we talked about fission and fusion in nuclear reactions. Stored mechanical energy is something along the lines of like stretching a rubber band or compressing a spring. If you were to just release that, it will turn into kinetic energy. So that's stored mechanical energy. And gravitational energy is what I was talking about. If you have something at the top of a hill, or say have something is suspended at a very high level, so farther away from the center of gravity, it's going to have a tendency to move towards the gravity. So if you just released it, then it would fall and it would create kinetic energy. So the most common form of kinetic energy that you're probably familiar with is motion, and that's what we just talked about, it something falling or running or whatever. That's motion. We've got other forms of kinetic energy. You've got radiant energy. That's the energy of light. We talked about light in the first semester. So anytime we're talking about the energy coming from the sun, that's a form of radiant energy, or energy that is coming from a heat lamp. So a lamp is shining. That is producing energy through light, and heat can be produced that way as well. Thermal energy itself is the main focus of this unit as far as kinetic energy goes, because thermal energy is heat, and we're going to talk a lot about heat. It's the internal energy of a substance, the vibration and movement of atoms and molecules within substances. Lots of different examples of that. Just mentioned motion. Sound is actually a reverberating pressure wave, and you learn more about that in physics class. And then, of course, electrical energy. We've talked about this before. Electrical energy is the movement of electrons. So, again, that's a form of energy that's related to chemical reactions and related to the electrons flowing. Again, our main focus in this unit is going to be chemical and thermal energy, but the first assignment or two, you're going to be looking at all of these forms of energy. Okay, one thing we want to keep in mind, there is a law of conservation of energy. Just like there's a law of conservation of mass, there's a law of conservation of energy, and then we want to talk about how energy can be transformed. The law of conservation of energy, similar to the law of conservation of mass, says energy can't be created, it can't be destroyed, but it can change from one form to another. So energy can only be transformed. It can be changed. It cannot be created or destroyed. We've got some examples of this concept of energy transformation. So a blender is used to make a smoothie. You plug it into an outlet, so that's electrical energy, but it's being transferred into motion. That's why the blades are spinning. So the electricity is causing motion. A gas oven is used to bake cookies. That's chemical energy being transformed into thermal energy, because the chemicals in the gas that's the potential energy. They are being burned. They're being reacted in such a way that produces heat, and that's how the cookies are cooked. And then charging your cell phone battery is actually electrical energy being converted to chemical energy. This one's a little harder to see, but anytime you have a battery, that's a chemical energy. It's a form of chemical energy. In fact, let's go back up here. I want you to watch out for that. Maybe just jot it down in your notes. Chemical energy, anytime you see battery, that is going to have something to do with chemical energy, because a battery operates off of chemical energy. So when a battery is being charged, you're taking the electricity from the wall and causing a chemical reaction, a reversible chemical reaction, to charge up in your cell phone, so that that same reaction can operate in the opposite direction and discharge and give your phone the electrical needs that it has. And then a windmill. Windmill spins because of the wind, and that generates electricity. Okay, next thing we're going to talk about is methods of heat transfer. So this is thermal energy. Very specifically, we're talking about thermal energy. Heat energy is used for a lot of different things, but the main thing I want you to get from this, and you know that it's used for cooking food and that kind of thing, it's also absorbed and released in chemical reactions all the time, but you've got to know that it flows from hot to cold. So heat energy always flows from hot to cold. So when you go in a really cold room, the reason you feel cold is not because you're absorbing coldness or cold from the room. It's because the heat that you have is being released to the surroundings. You feel colder because you have lost heat to the area around you or to your surroundings. We're going to talk a lot about heat flow in this section. When things heat up and the temperature increases, the reason is because the atoms or molecules of the substance are moving around faster. In other words, they have more kinetic energy. So how does energy flow? It goes from hot to cold, and it is transferred in 3 different ways. We've got conduction, convection, and radiation. Those are the 3 methods of heat transfer, and we're going to talk about each of them. Conduction's the first one. Conduction, I want you to think of the key word here. Conduction is direct contact or touching. Okay. So if you touch a surface and your hand feels hot because you literally touched that surface, that is conduction. Okay. Ice is being warmed up by drinks in an ice chest. There's direct contact between a colder object and a warmer substance, and that causes heat transfer. If a mother touches a kid's forehead to see if it's hot, that's direct contact. Convection is a little different. Convection involves the movement of gases or liquids to another area that's either warmer or colder. So the actual individual molecules of the gas or liquid, it's 2 specific states of matter, gas and liquid, the fluids, they'll flow and move around into different pockets of higher or lower temperature. Okay, so for instance, if you put your hand directly, I'm looking at the wrong thing. The air in the atmosphere is an example of that. The air in the atmosphere moving around because of temperature differences, currents, wind, that type of thing, that's all because of convection. Warm air rises when you're in a room. If you've got a lava lamp, those blobs that rise and then they fall again, that's because of convection. And then we've got this picture right here that kind of demonstrates it. if you have a candle that's heating a liquid, well, the molecules are flowing around in that liquid. That is convection. The heat it ends up being the same temperature. The whole substance, the whole liquid will end up being about the same temperature because those molecules that are really hot at the bottom will flow up to the top and they just keep circulating. Same thing if you put your hand over a hot object, you're not actually touching it, but you put your hand over the hot object. The reason you can feel the heat from that hot object is because of convection. Those hot gas molecules are moving around and they're coming in contact with your hand. Okay. Radiation is the last type of heat transfer we're going to talk about. And that is the one that is a transfer through electromagnetic rays or light with no contact, no touching at all. Best example of this is the sun heating up the planets. We have no substantial amount of gas between Earth and the sun, and yet the heat still is being transferred. That's called radiation, and it's being transferred through those electromagnetic waves. Light bulbs heating up a room, toasters and toaster ovens work this way. Infrared heating lamps, for instance.